Hey guys, in today's video I would like to show you some examples of the TRK mobile scanner data and a few tips and tricks in the Cyclone 3D, how to digitize it and extract some features.
Pegasus TRK is a new mobile scanner from Leica Systems which brings autonomy, intelligence and simplicity to mobile mapping and is set to transform mobile mapping with next generation AI capabilities. Past few weeks I had the pleasure to work with it by myself and I can tell that it was great time. Previously I have never worked with mobile scanners and I always thought that it was much more complicated than terrestrial scanning, but the workflow was very simple. The system always guides you and tells you what you should do next, so it works autonomously and does all work for you. But the most impressive part for me was the intelligent real-time auto-blurring algorithms that make your data secure and protected. The other side of the coin is covered by the new software for processing data like Leica Cyclone Pegasus. This software is intended to work with the data from mobile sensors. It can automatically determine common points between different tracks and adjust your trajectory by itself. And one of my favorite parts is the automatic classification of point clouds. You can achieve more than 20 different layers automatically. That feature really speeds up your processing time, and I decided to test the data with Cyclone 3D for classic feature extraction purposes. Let's start with the road stripes extraction. For that task we can use manual and automatic approaches. For manual creation of polylines, select the Draw Polyline tool and choose the snapping mode to white line. The polyline will be created at the axis of white line thanks to a seed point. You have to enter a search radius, buffer area where the software will recognize white lines. If your polyline contains too low number of points for an accurate representation of the curved lines, you can try to convert it to a spline. Click the Draw Cut Curve from the polyline tool. This command computes cut curve according to polylines. The line will be much smoother, but it will be another type of line. If you want to represent it as a polyline, you can convert it back with the Draw Polyline from cut curve tool. Also, for adding a new vertex to the polyline, you can hover the mouse over the blue middle sphere on the polyline and click on the appeared red arrow symbol. For the automatic creation of road stripes, we should filter the point cloud and segment from it points that are relevant only to the stripes. Use a different combination of filters for that task. Filter by real color. This command splits clouds according to the real color on each point. Points having a color similar to the selected one will be grouped in a point cloud. Filter by intensity. This command filters point cloud inside the clouds according to a range of inspection values, and segment by distance. I showed this filter many times in previous tutorials. This command splits clouds into a group of clouds based on the distance between points. When you will get a clean point cloud of stripes, you can use a simple script for line extraction from these clouds. For example, the electric line extraction script, which tries to fit polyline into selected clouds. Usually it's using for wires extraction, but you can change the sampling step to make it more suitable for road lines. Use the same script to extract wires, select a cloud and then point cloud to start the extraction. The electric line is extracted using a point on the line and a sampling step that includes the line. You could use the script to extract not only wires but almost any line object, for example some kind of fences also. For extraction markers on the road, same as for road lines, the first step should be filtering point clouds. Next, we can use geometry tools to fit them in the cloud where it's possible to represent the desired elements with basic rectangle and circle objects. Also, we can use combination of offset, transition, rotation and other transformation tools to speed up the processing. To extract more complex shape, use the planar contour command. The command allows extracting planar contours from meshes and clouds. After extraction, apply the resample polyline tool to them and specify desired number of vertices. The polylines will look much better. To represent the hardest shapes, we use the manual tools for creating polylines and then copy that set of polylines to other locations. For curbstones, we also go with manual ways and automatic ways with scripts. For manual extraction, click the Draw Polyline tool and set a snap to the ground point for extracting the lowest line of the curb. For the highest line, set the snap to the highest point. For the automatic way, you need to have at least one polyline that will represent the direction of the line that should be extracted. You can specify two lines, the bottom and upper part of the curb, and then run the pre-installed curb extraction script. The algorithm extracts the curves at individual points defined by the sampling step. This tool works pretty well, especially with the clean and accurate point clouds from the TRK. A few more tools that you could try for curve extraction purposes based on the mesh analysis, so for them you should create a mesh from the surface and curve points. Thanks to the classification in the Pegasus office, the point cloud is already split by relevant layers. All that you need to do is select the layers with the point cloud, group them and click the Scan to Mesh tool. It's one of the easiest ways to create mesh. When the mesh will be created, we can try to extract all lines with the multiple breaking lines tool. This command offers the possibility to extract all the breaking lines or feature lines from a mesh. The resulting lines are divided into two sets. The convex line in red corresponds to crest geometries and concave lines in blue corresponds to ravine geometries. One more unusual way to extract lines, which I showed in Scan to Plan tutorial, is to make a slope analysis, then segment the mesh by color and extract all borders as polylines. Anytime when we work with the automatically extracted lines, we should apply on them some filters to make them more smooth. After the classification of point clouds, we got layers with points relevant to the road signs and poles. Basically, it's just cylindrical objects, and we can use the best fit cylinder or best fit circle tools to extract information about their geometry. But before that, I prefer to segment point clouds closer to the ground, because upper points contain elements not relevant to the cylindrical objects. You can use previously created ground for that and the separate according distance filter. This command explodes one cloud into two parts using a selected object and the defined distance from that object. Use the different distances for sign and poles based on the shapes. The main goal here is to get a clean point cloud of cylindrical object. Use the segment by distance filter to split one big point cloud to separate files. Next, use the best cylinder tool and check the one shape per input option. The tool will give you the right geometry's object for all selected elements with one click. I prefer to convert this object to mesh with the mesh from object tool and extract the holes and borders as polylines. Then select the lowest part of each element and project it to the ground. It will give us not only X and Y information but also Z value for each element. If your final deliverable will be a 2D plan or 3D model in AutoCAD Civil 3D, then you can create the dynamic block with a different type of visibility and use multiple placement of this block based on information extracted from Cyclone 3D. Select all polylines that represent cylindrical objects and apply the best cylinder tool on them. Set the one shape per input option and use the below script to extract the center position of each geometry element. When the position of each element will be defined, copy it from the script window, then go to Civil 3D, select your block and click Copy it to. Pass to the command line previously copied elements and you will see that the software will insert the block to each single coordinate that you copied previously from Cyclone 3D. One more useful way of creating symbols on your topographic plan is the manual extraction of particular points and assigning them description codes with the virtual surveyor script from my colleague Kyle Palmer. This script allows you to label picked points in 3D in the viewing window and store the points with the feature code and comment concurrently to the selection. I prefer to select ground point snapping mode when I'm using the script to get all points with the right Z value. Try to use the same description codes as you have in your CAD software. It will allow you automatically generate all symbols based on the description. In Civil 3D it's called the description key sets. You can add any symbols you want and add to the special code. When you will import the coordinates of your points with the relevant codes, all symbols will be generated based on these sets. For tree extraction, first of all, we should define how we want to see the final result, as 2D symbol of each tree, as 2D contour of all tree crowns, or as a 3D object. For the 2D symbols, we can use the same tools as we used previously. For the 2D contour, we can use the same technique as I showed in the Scan to Plan tutorial. Project all three clouds to the ground surface, analyze mesh versus cloud and segment the mesh based on the analysis color, subdivide the mesh and repeat the previous step, extract all borders as polylines. Later, you could use the mesh to get all surfaces. For the 3D object representation, uses the region growth cylinder tool to represent the tree trunk and the convex hull to represent the tree crown. This command computes the convex hull of a cloud, that is to say a mesh that contains all the points. Later you could use the all generated mesh to get the crown volumes. For building there are also different ways of representation. You can create 2D plan or 3D model. In the scan to plan tutorial I demonstrated a lot of different workflows on how to extract 2D polylines from the clouds, use the scan to plan tool and the planar selection tool with the combination of editing polylines tool. For the 3D model creation, use the building extractor tool. This command allows you to create a simplified mesh based on planar parts of point clouds or a mesh. Click on the input object to extract planar areas and contours, validate the extracted planar contours, this will create a planar mesh. Repeat both operations to create planar meshes as needed. The connections between the extracted planes are calculated by default. However, you can force or remove some connections. To do so, all you need to do is drag one ball representing a plane onto another one to force the connection. In order to remove the connection, select the edge representing the connection and press the delete key. The user can manually define a plane by clicking on any number of points with the Shift key pressed. Pressing the Shift key will override the automatic plane extraction behavior. All points clicked with the Shift key pressed will be used to compute the best plane from these endpoints. One of the common tasks is also extraction contour lines. You can do it easily if you have a ground surface with the contour lines tool. Just select the mesh and run the command. Define the step between each contour line, choose the range of the contours, set the interval between major contours, filter contours smaller than specified value to remove irrelevant contours. Contours are created based on the triangles, so they could have rough shapes. To make them smoother, use the Smooth Polyline tool. If you prefer to create contours in other CAD software, you can export the mesh as a land.xml file and use it in your CAD as you wish. As additional deliverables, we can create different types of cross sections. For the transverse profile, create a trajectory first, then select it and run the section along curve tool. This command computes a set of planar sections along a polyline or a curve. You need to specify a step of section. You can define the step between sections and optionally arrange using custom. With a list of distances, you can type distances and or click points in the scene. Searching distances to draw the sections only in the curve neighborhood. The value corresponds to a radius. After creation, you can resample transverse polylines as you wish. For the longitudinal profile, you can use the below script. The script provides functionality to unroll a 3D polyline so as to plot a longitudinal profile. Create a sample polyline to represent the trajectory of the road, project it on the mesh with the projection tool, and run the script and select the projected polyline. The script will create the longitudinal profile, project it vertically on the horizontal plane and compare both lines. Later you can disable the comparison if you want to leave only the profile polylines on the screen.
I hope you enjoyed this video. I think the below tools could be suitable not only for roads with mobile scanners, but also for surveying applications with any type of scanner. And don't forget that Cyclone 3D got a lot of tools for analysis purposes that I didn't demonstrate it in this video. I think it will be a great topic for next tutorials. For today that's all. Thanks for watching and see you next time.